Okay, I'm just gonna. Hi, Akila. Have you met Akila? When did we meet?
I forgot.
Like last week?
I don't remember.
Oh, okay. But is this your first lesson?
I don't think so.
Are you a makeup student here? No, right?
No,
You did the test? Did you do a test?
no.
Oh. So this is your first lesson, lah. No, this is your first lesson.
Okay.
Okay, hey, I'm asking you, you're saying okay. Okay,
Okay.
yeah. First lesson. Okay, good. Okay, I just want to quickly go through the booklet A. Ken, I just go through booklet A, right? Just the booklet A part because it wasn't done well. Unfortunately, none of us got full marks. So we'll go through this. Which of the following is not an example of a force? Come, Nasira, which of them is not an example of a force? Ball bouncing the ball. What kind of force is there? Push force is there. What else is there? What pulls the ball down? Gravitational force. What brings the ball back up? Elastic spring force in a compressed air. Good. A pump inflating a balloon. Is that an example of a force? Yes, it is. It is an example of a push force. Roof blocking the sunlight is not the girl to switch on the light. She needs a force, right? So this is an example of a force. So based on this, option number 3. Straightforward. Marble R was rolling from point X to point R on a carpeted floor. It was hit by marble S, causing a change. Marble R continued moving and eventually stopped at point Y. Based on the experiment, what can be concluded? Remember, the key thing is based on the experiment. Can a force stop a moving object? Yes, it can, right? Frictional force, and that's why we see this, right? This is a frictional force. Good. A force can change the size of an object. Can. But in this question, was it observed? No, we didn't see the ball changing size. Okay, so in this particular place, it was not observed. A force can change the direction of a moving object. Yes, obviously, the ball was initially it was moving like this. Suddenly, it started to go there. Okay, so in this case, it did, and then the answer is A and C only. Option number 2. Okay, you got it right, Lasha, so far. Okay, question number 3. The boy released a ball from his hands and he kicked the ball up into the air. He kicked it up into the air. It came down and went up. When he kicked it up into the air, did he kick it into the moon? Cannot be. Nobody is so strong to kick something until it goes to the moon. So did the location change? No. It's still on Earth, right? When he kicked the ball, did the mass of the ball change? No. So if the mass of the ball didn't change and the location didn't change, what doesn't change? Gravitational force acting on him doesn't change. Why does this not change? Because mass is the same, location is the same. He was still on Earth. He wasn't kicking it so high that it went into space, right? It's still on Earth. If mass is the same, location is the same, did the amount of gravitational force change? Which of these graphs shows that the amount of gravitational force is not changing? Option number 4. Okay? Okay? Easy? Ayla, you got it right? No, right? What did you choose? 2, right? 1, right? Why? Okay, because you see, and this means the mass goes down, then the mass goes up, then the mass goes down again. Or it could also mean he went to the moon, then he came back to Earth, then he went back to the moon again. It doesn't make sense, right? Okay? So it's the same place. So will the gravitational force change? No, it remains the same throughout. Okay, question number 4. Bell hung 2 identical objects. Santosh, your worksheet is with me. Santosh, camera's on. Bell hung two identical objects, A and B, on two identical springs. A was hung in the air while B was hung in a container of sand. She then lifted the two springs with the object upwards by 5 cm. Which of the following statement is incorrect? More force is needed to lift B. True or false? True or false? True lah. Why? Because over here there's nothing pushing it
True.
down. Over here sand is pushing it down. Yes. Gravitational force is acting on both A and B. Is that true? Yes. Why is it acting on A and B, Lashira? Why? Oh, we talk about gravity, not spring. Why gravity acting on A and B? Simple answer. No need to think too much. Why? No. Simple answer. Where is it? It's on Earth, right? So every time it's on Earth, gravitational force is acting on Earth, right? This is true. More gravitational force is acting on object A than B. Is that true? Sarah, is that true, Sarah? Is that true? Yes. Why, Sarah? Why is there more gravitational force acting on A? Why? What does gravitational force depend on, Ayana? Two things. Gravitational force depends on two things. What are they? Mass and location, right? Is the mass of A and B the same? No? Why not? How do I know it's the same? The question says they are identical. Identical means the mass is the same. Only problem is one has sand on it. That's it. But we're talking about A and B. Can it be different? No, it should be the same. Why? Is A on Earth and B in the moon? No, it's not. Both A and B are on Earth. Both A and B have the same mass. Is there more gravitational force? Cannot be. It should be the same amount of gravitational force. There is more force acting downwards on B because of the sand. Is that true? Yes, right? Because why? We are trying to pull it up, but the sand is pushing it down. Okay, so this is true. So based on this, which is the answer that is false? Which option is false? Which is incorrect? Option number 3. Do we all okay? Arisa okay? Oh, wait. Your name is Arisa, right? No, it's not Arisa. Arisa? Arisa, what's your answer for question 5? Sorry. 5. What you put? What's the answer question 5? Hi,
3.
Akila. Have you learned forces already? Arisa, yeah, give me answer first, then I talk to her.
3.
3. Okay, Arisa put 3. At which point did the gravitational force act on the toy? Only at point B and point C. Why? Why, Arisa? Why A don't have? Is it like this? Earth, space, Earth, space. Is it like that? All right. So what should the answer be, Arisa? Sorry. Louder. All A, B, C, all on Earth, right? Anytime it's on Earth, is there gravity acting on it? Yes. Do we get it? So what's the answer, Arisa? What's the correct answer? Is it number 3? Zahirul, 3 or 4?
4.
Oh, good. Because everything is on Earth. A is on Earth, B is on Earth, C is on Earth. Unless they tell you there was a rocket ship, like there's a Earth like that, okay? Then there's a rocket ship. Who's a good drawer? Can you draw a rocket ship taking off into Earth? Please come. They're on the Earth. Oh, nice. Okay. Nice. Good. Good. What is that? Oh, you're really good at it. Good. Okay. Thank you. Okay, cool. Right. So, for example, right, in this case, in this case, okay, right? If the rocket ship is on Earth, there's gravity acting on him. But as he flies up, slowly away, once he goes into orbit, there's not much gravity acting on him. Is that okay? Then it will change. But if they're on Earth, it will always be the same. Is that okay? Can? Right, next. Question number 6. Okay, Fahan kicked the ball. Fabian kicked the toy upwards. The toy traveled from point X, where Fabian's shoe hit the toy, to reach the highest point Z, as shown below. Sarah, what's the answer for this? A, B, and C. All the points got gravitational force. I know what's the answer for question 5. Sorry, Sarah?
4.
4. Good. Okay, you're right. It is 4. Why? Because you see, what is gravitational force doing? What is gravitational force doing? Pulling the thing downwards. What is the push force doing? Making it go upwards. In which direction did this ball go? Did it go downwards or did it go upwards? Upwards. So which force is greater? The push force. Simple. That is why the push force is greater than, or in this case, the gravitational force is less than. Remember, gravitational force is pulling it down. Push force was pushing it up. Because it moved in the direction of the push force was greater. If the ball, after you kick and the ball still fell down, then which force is greater, Ayana? Gravitational force or push force? Imagine the ball is coming down, okay? A big bowling ball is coming. Then you use your hand to hit it up, but the ball ignores your hand and goes down. Which force is greater? Gravitational force, which is why it goes in that direction. Objects always move in the direction of the force that is greater. Okay? So when I throw my phone, why does it go up? Because my push force is greater than gravitational force. But there comes a point in time when my push force, why does it become lesser? Because of friction, right? The air resistance coming down, correct? Then what will happen after that? Gravity will take over and start to pull it back down. Is that understood? Okay? Okay. Right, next. Look at this. At which points will, this is the same question again and again, gravitational force be the same? Akila, at which points will it be the same? What does gravitational force depend on?
Objects.
Okay. Thank you for your answer, Akila. I like your enthusiasm. Yes. Santosh, what of objects? Akila say objects, but can you help her a little bit? Add on some more. What does gravitational force depend on? Two things. What are the two things?
Mass
Mass and
and weight.
okay, weight is because of gravity, okay? Mass and location. Is that okay? Okay, never mind. You can forget about location because I don't think they teach you like the rocket ship going from Earth to space. So everything is on Earth. So we talk about mass. Okay. So as the car is traveling down this thing, did the mass of the car change? No. Did it go like this, go into space, then come back into Earth?
The car of the mass did not change.
The car's mass does not change. So does the gravity change or not? No, because the mass is the same, the location is the same, amount of gravity is always the same. So at which points is it the same? On A is the same, B is the same, C is the same, D is the same. I know, okay, not? Okay. So what's your answer? Not two. What should it be? What should it be? I know what should it be? Okay, write down. Gravity depends on mass and location. Okay. Okay. So imagine we start the car. Let's say the mass is 10 gram. And where is he? On Earth. Then at point B, what will the mass be? Same. Mass will be 10 gram. And where is he? On Earth. At point C, what will the mass be? 10 gram. And where will the car be? On Earth. At point D, what will the mass be? 10 gram. Where will the car be? On Earth. So based on this, none of these points, mass didn't change, location didn't change, gravity is same in all of them. Is that okay? Okay. Arisa, sorry, Sarah, I haven't heard from you. Sarah, what's your answer for question 8?
4.
4. Yeah, magnets can act from a distance. Can or not? Can. Magnets allowed to attract a piece of iron? Yes. And magnets are stronger than the poles? Option number. Zahirul, what's your answer for question 9?
I'm taking my paper.
Oh, okay.
Question 9.
Yeah.
2.
2. Okay, B and C only can. Okay. Okay, now let's look at the options. Okay, so you're saying B, mass of the ball will change. Can force change the mass of a ball? Can force change the mass? Can never, right? Santosh, can force change the mass? Remember our topics we learned, right? What can a force do? Right? Can force change the mass? Force cannot change the mass. Huh? Remember, forces cannot change the mass. Remember, force cannot change mass. Okay, Zahirul? Force cannot change mass. Okay, so the mass of the objects will never be changed. Cannot. This is not an effect of forces. Can force stop a moving object? Yes. Can
Yes.
force change the direction of an object? Yes.
Yes.
Can force change the speed of a moving object? Yes.
Yes.
So based on this, which are they possible? Option number. Is that okay, Zahirul? 10. Sarah, back to you. Question number 10. What's your answer?
1.
1. Okay, so Z up Z lead the knees force. Why? Because gravity is helping it and there's wheels to reduce friction. So you need the least force. Whereas here, if you look at setup X and Y, here gravity is helping it, here gravity is not helping it. So X needs the most force, option number 1. Anyone got this wrong? What do you do? 2. Oh, wait. Okay, you see, you imagine this. Okay, you have a skateboard to pull a box, and you're pulling it down a ramp. Here, no, nothing. No, you just got to pull it on a flat floor. Which is easier? X is easier than Z. Z, right? Obviously, because when you're coming down and you have wheels, right? So it's quite easy to pull it down. Think about it, right? So which one will lead the least force? Obviously, C. Which one will lead the most force? X. Okay. Okay. Good. Question 11. Akila, you never do the test, right, Akila? Do you do the test? Akila, which school are you from?
That song.
Guachong. Okay. Nice. Cool school. Have you heard of Guachong? Arisa, what's your answer for question 11?
3.
3. Cool. Okay, why 3? Ooh, okay. Okay. So when the magnet attracts, okay, the magnet is attracting the object. So this is magnetic force, which is good. Frictional force, the object moves this way. This is moving, right? And friction acts in the opposite direction. So friction is this, correct? And when that happens, the spring is compressed. So the spring wants to return to its original length, which is like this. Okay? Okay? So what is magnetic force? Like that. Frictional force is like that. And like that. Okay? Oh, my mistake. Sorry. See, this is what happens when you don't read the question carefully. Okay. Now, the object is sitting like this normally. Okay. So once she brings a magnet towards it, the object repel. Why did the object repel? Why do you think it repelled? Why do you think it repelled? You see, I moved away, right? It was a normal spring, suddenly the object moved away, correct? Why did it repel? Because it is the like pole of another magnet. Okay. Do we understand? So magnet are pushing it that way. Magnet is pushing it that way. So it's moving in that direction. Friction is in this way. Friction opposes motion. And remember, when the spring is compressed, it wants to return to its original length. So this is elastic spring. Okay, so this is magnetic force. Magnetic force is that direction. Frictional force is in the forward direction. Elastic spring force is away. It is option number 1. Okay? Arisa, okay? Do you know why it's 1? Question number 12. Santosh, what was your answer? Coach, I don't know, coach. You have my paper. Right now. Yeah, I tell you what your answer was. Your answer was okay, you got it right. I know what's your answer for question 12. 3. Okay, cool. Anyone got a different answer than 3? All of us got 3? Anyone got it wrong? No, so I don't need to explain, 3. Okay, why? The spring returns to its original length. Simple as that. Cannot be stretched more, will not be compressed, it's not even compressed to begin with. Okay, good. 13. Lashira, what's your answer for 13? Get it correct? Okay, 13. Zairul, what was your answer for 13, Zairul?
Put 3.
Sorry, you put 3. Okay, let's analyze 3. Okay. So now the plastic moved from the floor to X and then to Y, and then it stopped at Y. So it was moving from X to Y, and then it was stopped at Y. So the question says at point X it was moving. And at point Y it was stopped. Now, what we learned, when something is moving, there is friction. When something is not moving, there is no friction. So let's look at it. At point X, is there friction? Yes. At point Y, is there friction? Is there friction? Is there friction at point Y? No. Why is there no friction at point Y? I know why no friction at Y, Ayana. Because it's not moving, exactly. So the answer is option number 2, straight away. Weight is because of gravity. Gravity should always be there. Gravity should always be there as long as it's on Earth. Okay. Zyrul, okay? You understand why it's not 3? Oh, this was a tricky question. Okay. Wait, I'll give you 1 minute. Give me 1 minute. I'll just cut that. Okay. Sarah, what's your answer for 14, Sarah?
4.
4. Okay, can. Now, if you look at this, they conducted an experiment using springs X and Y. She hung different loads one at a time on the springs and measured the length of the springs. Okay, so when it says 0, that means what is 15 cm? 15 cm is considered the original length of the spring. 15 cm is the original length of the spring. Now, when I add 4 grams, for example, right, spring X extends 4 cm, spring Y extends, spring X extends about 2 cm, spring Y extends about 5 cm. So which one extends more? Spring Y. Because spring Y extends more, we say there is a more elastic spring. And spring X is a more stiff spring. Okay. Easy? Now, spring X is stiffer than spring Y, which is true. Spring X extends by 25 cm when a 8-gram load is hung on it. Let's look at 8 grams. 8 grams is here. Does it extend by 25? Obviously not. It doesn't extend by 25. It extends only by 10 cm. So B is wrong. Spring X is shorter than spring Y when a load of 14 grams is hung on it. Let's look at the total length when 14 grams, right? Spring X is about 25 cm. Spring Y is about 32 cm. That statement is true. So based on that, it's option number. Anna, did you get 4? Okay. Two springs M and N have the same length when two identical blocks are hung, and the results are shown below. How many grams is acting on spring M? How many grams is acting on spring M? 400 grams. Good. Spring M actually has 400 grams. And spring N has 200 grams. Which one extended more? M or N? N. N extends more. Okay. So N is more elastic. Okay. Is that okay? So for example, let's say the same length we start with, let's just say, for the sake of it, 5 cm. Spring M to extend 5 cm, he needed 400 grams. But spring N to extend 5 cm, he only needed 200 grams. So based on this, I know spring N is more elastic and he will extend more. Okay, so it's not this. Spring is not this. Okay, spring N, it will extend more than spring M. Okay, now why is this wrong? Why is number 3 wrong? Why is number 3 wrong? Is it a microscopic spring? No. Can I see the spring, Lashira? Can I see the spring? Can, right? Is it microscopic? Will the length ever be 0? The spring will never be 0 cm, right? Will the spring ever be 0? You will never be 0. I will always see the spring, which is why it always has some length. Okay, so based on this is option number. Hi, Arisa. What's your answer for question 16? You learned energy already, Arisa. Is it? No, I'm just wondering. I'm genuinely curious. Is it? Because your answers are even for this, right? Okay. See, gravitational potential energy will change. Okay, as the height changes, gravitational potential energy changes. Like here, there is a lot of gravitational potential energy. Here, there is no gravitational potential energy. Okay, but I realize your answers are. Have you learned energy somewhere outside? Oh, okay. Remember, gravity and gravitational potential energy are different. I repeat again, gravitational force and gravitational potential energy are different. Okay, one is a force, one is energy. It's slightly different. Okay, Ken, is that okay, Risa? Okay, so we come back to this. Ken, now when we look at this, there are two forces acting on this man. What are the two forces? Gravitational force. What is gravitational force trying to do? Trying to pull him down. Okay, gravitational force is trying to pull him down. Again, friction is in the opposite direction. But what else is acting on him, Ayana? The air that is blowing on him, right? The push force from the air. Is that okay? Okay. So this is gravitational force. This is a push force, right? Now, which is greater? Sarah, if gravitational is greater, this man will go down or go up?
Down.
Down. If the push from the air is greater, will he go down or will he go up?
Up.
Up. But in this case, he was able to stay afloat. Which means what? Both are the same. Arisa, okay? In this case, because he's there, he's not going up, he's not going down. He's remaining there, which means both of them are the
Same.
same. Exactly. So the gravitational force is equal to the push force of the air. Okay? So that is why it is option number 4. So the push force and the gravitational force are the same. That is why he can stay afloat. If he wasn't the same, if he was going upwards, which is greater, Ayana? Push force is greater. If he's starting to fall down, which is greater? Gravitational force. Is that okay? If he's going up and down, up and down, up and down means changing. Push force going up, gravity. Okay. Is that okay, Arisa? Did we get this? Okay. Can Ron conducted an experiment using the setup shown below? Okay, I tell you what, you're all sleepy. I give you a 7-minute break now. You go for a 7-minute break and come back. I'll see you all in 7 minutes. This is the first thing is go. Okay, Ashira, can you go where's the toilet, where's the snacks, okay? Okay, I'm gonna go. You know why I can't put a magnet? Why I can't put a magnet? I know what you got for this, right? You understand why it's not number 3? Because if the gravitational force is more than if the push force is more than its weight, will it float or will it go higher? Yeah, but will it go higher? Which school are you in? Sorry. Which school are you in? Okay, I'm done. Hey, Akila, your first lesson today. That's why I don't remember you. Have you seen me before? No, right? Which school are you in?
Da Chang Primary School.
Which school?
Da Song. Wait,
Oh, okay. I think it's your first lesson, right?
yeah.
Okay, so you will be lost because I'm going through concepts that we've already covered in this topic called forces. Okay. Oh, that's all. Okay. Okay. But don't worry. With the next topic we cover will be energy and food, and then you can catch up to speed. Okay. I'll do a revision on forces again sometime in March. So maybe but then you can catch up again, okay? Because this is a concept we finished. We already went through the lesson in class. Okay, these are the topic on forces, and then this is the test that is just covering these concepts. Okay, okay. So you may be very lost in this, but don't worry, we'll do another revision in March. Okay. Okay, so you just follow through, try and pick up as much as you can. Then the next following lesson, when we do energy in food, you'll be back to speed with the rest of the class. Okay? Okay. So Ron conducted an experiment using the setup below. He pulled the steel block up the wooden plank. So he's going up. Remember, what are the forces when the thing is moving? There's gravity pulling him down. There's frictional force, which is opposing motion. Okay. And the question says he wants to decrease the reading on the spring balance. Now, there's two ways I can decrease the reading on the spring balance. Number one, I can decrease gravitational force. How do I decrease gravitational force? Santosh, how can I reduce the amount of gravity?
Put lubricant.
Gravity. Okay, we talk about, yeah, friction, yes. But if I want to reduce gravity, what should I reduce? Arisa, what should I reduce? Remember, two factors affect the amount of gravity, right? What are the two factors? Mass and, can I change the location? Cannot. But what can I change? Mass. So I can reduce the mass. Okay. And number two, I can reduce the amount of friction. How can I reduce the amount of friction? I can do two things. What can I do? Add a lubricant, or I can add. What else can I do? Zairul, besides adding lubricant, what can I do? Add wheels, or I can make it a smoother surface. Okay? Can? Is that okay? Do we understand? Okay. So let's look at option one. Wrap the steel block with sandpaper. My goodness, when I do that, what will I increase? Rough. I make it rougher. And when I do this, I will increase the amount of friction. When I increase the amount of friction, will it be easier or harder? It will be harder. Number two, put a magnet under the steel block. Now, what's the problem with putting a magnet here? You see, when I put a magnet here, magnet will attract steel, correct? Magnet will attract steel. Now, when I put a magnet here, there is an additional force I need to oppose. Will it make it easier? No, it will make it harder. Why will it make it harder? Because remember, there will be an additional force to oppose. Do we understand? So will it become easier? No, it will become harder. Finally, put some oil onto the surface. Will this help? Yes. Why will this help? It reduces the amount of friction because oil is a lubricant. Okay. So what's the answer? Option number 2, C only. Okay. Okay, question 18. A spring was attached to the wall and block Y was attached to the spring and left to rest. A magnet was then brought near block Y as shown in the diagram below. So now the magnet will attract block Y. When it attracts block Y, the spring started to stretch. And when the spring stretches, elastic spring force wants to return back to the original shape. So it's pulling the block back. Magnet is pulling it that way. Elastic spring force is pulling the block back. There's one more force acting on this block. Do you know what it is? What is it? Where is this block? On Earth. What force acts on it on Earth? Gravitational force. Gravitational force always acts on the guy, right? So this is elastic spring force pulling him back. This is magnetic force attracting him and gravity as usual. So which of the following acts at block Y? Is there gravitational force? Yes. Is there magnetic force? Yes. Is there elastic spring force? Yes. So based on this is option number. Zairul, okay now? Okay. 19. Arissa, what's your answer for 19?
Oh. Oh.
What's your answer for 19?
Oh.
4. Hey, no gravity, yeah. Can't be right. Where will there be no gravity? Is he climbing a space rock? No, right? Think about it, Arisa. He's on Earth. Every time he's on Earth, there is gravity. Unless he's in like space climbing, then you need like oxygen mask, all right, because there's no air, there's nothing. So can there be no gravity, Arisa? Cannot be. Definitely there will be gravity. The weight of the man is greater than the gravitational force. Can that make sense? Definitely not. Because why? What is weight? Weight is the force of gravity acting on a person, right? Or on an object. So weight and gravity is the same thing. You have weight because of gravity. What is gravity? Sorry, what is weight? The force of gravity acting on an object. Okay? So it's obviously not number 3. Number 3 doesn't make sense. Right? Number 3 doesn't make any sense. Because why? Weight and gravity is the same, right? It's it's the same way of saying it, right? The weight is equal to the gravitational force acting on it. Okay. Is frictional force greater than the weight of the man? Yes. Because what is pulling him down? Weight of the man is pulling him down. Friction is helping him to stay up. Number 1, frictional force increases as he climbs up the wall. Is that true, Santosh? Is it true? What does frictional force depend on? Sarah, what does frictional force depend on? 2 factors. What does frictional force depend on? Mass and
Location.
no, friction. Mass and no, cannot forget all these. See, this is why that revision schedule was very important. Remember the first thing I told you, how you must study. If not, the forgetting curve tells you you will forget. If you don't follow the revision curve, you will forget. Science tells you you will forget. Okay, so remember again, what is friction dependent on? Friction is dependent on 2 things. Friction is dependent on the mass and the texture. That's it. Remember, a rougher texture, more friction. Smoother texture, less friction. Greater mass, more friction. Lesser mass, less friction. Okay, so remember, friction is dependent on mass and texture. Did the mass of the man become more as he climbed up? No. Did the texture of the rock surface become rougher as he climbed up? No. So did the amount of friction change as he climbed up? So the friction remains the same. Why? Because the mass was the same and the texture of his hands, the texture of the rock he's climbing was the same. So did friction change? Didn't change. So what's the correct answer? Option number 20. Zyrul, what's your answer for 20?
1.
1. What is the concept here? The greater the friction, the greater the force needed to move. The lesser the friction, the lesser the force needed to move. Which of these has the least friction? B. B is the smoothest. Which is the roughest? C is the roughest. Now, when it is roughest, there is more friction. Sorry. And this one has more friction. Now, let's look at this. When I'm pushing the box up the ramp, okay, I'm pushing the box up the ramp, the friction acting is in the opposite direction. Should I have a lot of friction or little friction? Little friction. So which object should the ramp be made of? A, B, or C? B. Good. So this is straightforward. Same like what Zairul asked. But the problem is, Zairul, imagine my shoes also slippery, Then can I push the ramp? What will happen to me? I will slip and fall, right, Jairo? If I use something so smooth for my shoes, what will happen? When I'm trying to push, I will slip and fall. So which one should I use for my shoe? Arisa, which one should I use for my shoe? A, B, or C? I don't want to fall easily. Which one should I use? A, B, or C?
B.
B. I don't want to fall, no?
C.
If I fall, then I have a problem, right? Imagine if I use my shoe like B, I look like this. I show you. I look like this, If I use my shoes as B, I look like this. I'll end up like this. See, like this guy.
Market's dipped. Do I buy? Or not?
See, like this. Why he slip? Why he slipping? Oh, there's not enough friction between the shoes and the floor, right? See, like this. Imagine I have very little friction. I'll end up like this guy. What thing? You see? Cannot walk. Right now, Jairus. So should I see he slip what? Poor thing. They are not helping him, just laughing at him. So my shoes, what should I use for my shoe? Santosh, A, B, or C, Santosh, for my shoe? A, B, or C? Which one should I use for my shoe?
C.
C, good. I need the rougher surface. Is that okay? If I have a smooth surface, what will happen, Ayana? I will slip and fall. Yeah? Okay. Question number 21. Let's look at this. The graph shows the extensions of springs. Oh, this is actually a very tricky question, Okay. A very tricky question. Let me repeat. This is a very tricky question. How many of you got this right? Oh, nobody. Okay. Yeah, I assume as much. Okay. Now, which spring extends more? Which spring extends easier? P. So P is what we call a more elastic spring because it extends more easier. Q is a stiffer spring. Okay, so let's look at this. Option number one. Option number one says P is stiffer than Q. Is that true? No, that is false. Okay, we learned that is false. P is longer than Q. Is that true? Think about it. P will be longer than Q if I add 50 grams to it. Because, what is extension? Exactly. So why is option number 2 not true? Is because I do not know the original length. Do you understand? I don't know the original length. Remember, this question is asking based on the graph alone. Okay? Based on the graph alone, I don't know the original length. Can I say P is longer? It could be that Q is a 100 cm spring, no? And then it just extend like that. And P is a 5 cm spring, and then it extend like this. Will it make sense? Is it fair? I don't know the original length. Okay? Spring P and Q have the same length. Is that true? Is that true? Because why? I don't know the original length. Exactly. P can be a 1000 cm long spring. Q can be a 5 cm long. I don't know. I really don't know the original length. Based on the graph, it doesn't tell me. The graph only tells me the extension. Then the last one, if they have the same mass hang on them, they have the same elastic spring force. This is true. So it's option number. This concept I was not taught. Okay, this was not taught. But how do you arrive at this answer? Is by applying the method of elimination. Right? Okay. Is by going through the options and you getting them wrong, 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 and this is the only choice left. So in PSLE, they have things like this. They will give you a concept that is true but has never been taught. They have questions like this. They'll tell you a concept that you've never learned, but it is true. And how do you arrive at the answer? By doing the method of elimination. Do you understand? Right? We've been doing this all along. You see the entire paper, we are doing elimination, getting our correct answers out like this, right? So this is why this method of elimination is important. Because in PSLE, like this concept was never taught to you. Did I teach you that same mass has the same ESF? You don't. But you know the rest. So based on the method of elimination, you arrive at the answer. PSLE is the same thing. You don't know the heat conductivity of a turkey, for example. Do you know? You don't know. You don't know if turkey is a better conductor of heat than chicken. Do you know that? You wouldn't know. But if you apply the method of elimination, you can arrive at the correct answer. Is that okay? So there will be things that they will test you that hasn't been taught, but you need to apply the method of elimination to arrive at the answers. Okay. 22. The diagram below shows the movement of a gymnast as he runs from jump board A to D. Which of the following identifies the forces acting on her as she moves from B to C and then from C to D? Okay, so now she's in the air. Okay, imagine this gymnast, she's in the air. Ooh, like that. Wee. Okay, when she's in the air, what is pulling her down? Gravitational force. Easy, yeah? Easy, right? We all understand this. Okay, then when she lands on this, this guy, then he land here. Then she must go down, right? But suddenly she jump up. How come she go up? Very good. Because what happens when she jumps on this, the spring will compress. And when it compresses, it wants to go back to its original shape, which is upwards. And when it does that, what does it do? It pushes the gym. Exactly. So what is the upward force? Elastic spring force. So based on this, option number 2. I know you got this correct? Good. Okay, question number 23. A man kicks a ball with an upward force F. Which are the forces acting on the ball at point X? Okay, so at point X, let's look at X. At X, is it on Earth? Is it matter? Yes, it is matter, right? So therefore, what is acting on it? Gravity is always acting on it. Is he moving? Is he moving? Yes, he's moving, right? When he's moving, every time he's moving, there's always friction, right? Friction is there because friction opposes motion. So is there friction? Yes. Is there gravity? Yes. Now we look at force F. Is force F acting on the ball? Is force F acting on the ball when it is at X? You know Bruce Lee, yeah? How many of you know Bruce Lee? Bruce Lee, yeah? You know he has this technique, he can punch like that, haven't even touched your body, but you feel the force. Why? Do you think that's real? Okay, wait, I show you Bruce Lee's punch. Imagine you're here, you're standing here, okay, and you punch someone, okay, and the other person is standing there. You don't even touch him. Do you think he will fly? Why? You never touch, right? In order for the push force to work, he must touch the person. At point X, is his foot still touching the ball? Can he like that only then the ball fly? Can it be like this, this thing, Okay, imagine this ball. I just boom like that without touching the thing. Do you think the bottle will move? No, because I'm no longer touching. Remember, there are certain forces that need to be in contact to operate. Certain forces don't need to be in contact to operate. Like magnetic force doesn't need to be in contact. Gravitational force doesn't need to be in contact. All other forces need to be in contact. So is force F acting at point X? No. Why is it not acting? Because it is not in contact. So what's the answer? Option number 4. Do we understand this? Easy? Okay, 24. Okay, let's look at Z. How many kg is acting on Z? Z is 2, 5, 6 kg. On X, there is 5 kg. And on Y, there is 3 kg. Same thing, Y has 5 kg. X has 4 kg. And Z has 2 kg. This is a math question. Z has 7 kgs. Y has 4 kg. X has 3 kg. Y has 6 kg. Z has 4 kg. X has 3 kg. So now it tells you what is the maximum it can hold. Can Z hold 6 kg or not? Maximum Z can hold is 7. So do you think Z can hold 6? Okay. Can X hold 5 kg or not? Cannot. Because the maximum it can hold is 3. Option 1 is out. Can Y hold 5 kg? Yes. Can X hold 4 kg? No. Maximum we can hold is 3. Can Z hold 7 kg? Aina, can Z hold 7 kg? Yes. Can Y hold 4 kg? Yes. Can X hold 3 kg? Yes. So option 3 can. But we cannot stop here. We look at option 4. Option 4, can Y hold 6 kg? Huh? Cannot. Maximum we can hold is 5 kg. So based on this is option number. This is an example of logic. Okay. What time your class, eh? Okay. Must read the question carefully, okay? Now, Victor added a strong magnet to a spring and placed it at the top of a ramp. He added a lubricant to the surface and placed a steel coin at the bottom of the ramp. He observed that the coin moved, okay? So when the coin is moving, what kind of force is acting on it? Frictional force is acting on it. The coin is on earth. What kind of force is acting on it? Gravitational force is acting on it. The coin, why did the coin move? Sure. But just I put a ram and I put lubricant, will the coin move? No. Why coin move up? It's attracted to the magnet. So was magnetic force acting on the coin? Was the spring ever touching the coin? Never. Is there elastic spring force? Don't have. So what are the forces? Magnetic force, frictional force, gravitational force, elastic spring force? No. So based on this is option number 3. How many have you got it wrong? What do you choose? 1. A and D. Elastic spring force. You choose elastic spring force. Why? But the spring is not touching the coin. Remember, for elastic spring force, the object has to be in contact. Has to be in contact, huh? If it is not in contact, it won't exert a elastic spring force. Remember, elastic spring force is exerted only when it's stretched or compressed and in contact. Okay? Remember, we learned that the forces that need to be in contact to work, right? There's two forces who need to be in contact to work. Where's that page, huh? Here. They need to be in contact, right? Elastic spring force. Did the spring touch the coin? Never. Aina, what was your answer? Sorry? 4 also. Same thing, huh? Did the spring touch the coin? Zyrul, what was your answer, Zyrul? 3. Oh, that's good. Nice. Sarah?
1.
1. Okay. See, elastic spring force again. Did elastic spring force touch the coin? No, huh? That means you must read the question carefully. You didn't read the question. You see, acting on the coin. They're not asking about the magnet, but acting on the coin. Did the spring touch the coin? Never. Arisa, what was your answer?
3.
Martha, you give him
Good. Very good. Nice. Okay, let's look at question number 26. A wooden block moved down the ramp after it was released as shown below, which shows the amount of gravitational force and the direction of gravitational force and frictional force. Now, if the ramp is moving, if the thing is moving in this direction, friction acts in the opposite direction. So this is friction. This is what I taught you just before your test. Remember, I talked about gravitational force. Gravitational force will act directly down. Huh? It always acts directly down like this, okay? Is that okay? Okay? Okay, cool. Now, let's look at the amount of gravitational force. What does the amount of gravitational force depend on? Arisa?
Okay.
I only got 2.
What does the amount of gravitational force depend on?
Do you have a snail? Like extra snail?
Extra snail? Is your mom asking for an extra snail? Like nail, that is? Is it? Do you have snails at home? That's so fun. I wonder what you want to do with snail. Is it snail, Arisa? Is it snail? You really have snail? Like, who keeps extra snail? Like, okay. Is it this? Is it this? No, okay, something else. Okay, my bad. Okay. Zyrul, what does gravity depend on?
Mass and location.
Very good. Did the mass of the wooden block change as it moved down? No. Did it move from Earth to somewhere else? No. Will the amount of gravitational force change? Will not change. So the amount of gravitational force will remain the same. How is gravity? It is like this, and friction is like this. Okay? So even if you didn't know the fact that gravity acts straight down, by method of elimination, you know that's the only option. You see? Even though we didn't learn that, we know that friction opposes motion. We know gravitational force remains the same. So the only answer is option number 4. Okay? Okay. Question number 27. Tell me, Ayana, what should the answer be? Should be what, Ayana? 3. Good. Why 3? Exactly. It didn't change mass, didn't change location. So the amount of gravity shouldn't change. So it's option number 3. Arisa, I think you chose 1, right? Yeah, you see, you're confused the gravitational potential energy and gravitational force. Sarah, what do you choose?
3.
Good. Right. Zairul, what do you choose? 1. But now you know the difference, huh? Remember, gravity doesn't depend on height above the ground. It only depends on mass and... Okay, let's look at this. The diagram below shows a spring before and after a 500-gram load was hung on it. The spring remained unstretched. Keyword here, unstretched. What was the answer? Got it correct? Okay. How about you? Aina, what did you get? 3. Okay. Sarah, what was the answer for question 28?
3.
3. Oh, all of us got it right. Okay. Santosh? Santosh, I tell you what you put. Santosh put... Santosh also puts 3. Okay, again, good. Right? There's no gravitational force acting on the spring. That is untrue. Because why? It is on Earth. It is matter. Gravity always acts on anything. There's no gravitational force acting. The gravitational force is not enough to stretch the spring. This is true. That's why it remained unstretched. There is no elastic spring force, which is true because elastic spring force only happens when the spring is stretched or compressed. Gravitational force is the same direction as the elastic spring force. Therefore, the answer is option number... Hey, why did I mark this wrong? This is correct. There is no elastic spring force because why? It is not stretched or compressed. Gravitational force acting is the same direction as the elastic spring force. Definitely not. Why is this wrong, Santosh? Why is D wrong? Why do you think D is wrong? I know why is D wrong. Why I never choose D? For the very simple reason that there is no elastic spring force at all, right? So how can I talk about direction? Why is there no elastic spring force? It's not being stretched or compressed, exactly. So based on this is option number 3. Question number 29. A strong magnet is fixed to the base of the ramp. A wooden block with an attached spring is released along the ramp. So this wooden block will start to fall down. Why will it fall down? When it's moving, it will as it moved, okay? Good, you're right. So as it's moving, there's always friction. Why is it going down? Because of gravity is pulling it down, gravity is there, friction is there. Is there a magnet? No, why no? It's a wooden block. Will the magnet attract the wooden block? No, definitely not. Why is there no elastic spring? The spring is not attached to anything. The spring is just moving with the block. Okay? The spring is not stretched or compressed. It is just moving with a block. So based on this, the answer is option number. Or in other words, even if you don't know if elastic spring force there or not, you know that magnetic force is definitely out. Okay? Based on that, you eliminated the other 3 options. Did you get it correct? You got it correct? What do you choose? 4. Why is not okay? Why is there no magnetic force? Because this is wooden block. Will it attract? So there's no magnetic force. Okay. Last question. What is the effect of the force? Concept here, the greater the force, the greater the effect. What is the effect of the force here? Effect is change the shape. Okay? Which one changed the shape the most? Why? Change the shape the most. Which one changed the least? W changed the force, shaped the least. Which one had the lowest height? X. X was from the A. Which one was the lowest height? Huh? Which one is from the lowest height? Which one I dropped from the lowest height?
Oh.
Why? I dropped from here, the thing become like that. But I dropped from higher up, it remained as a ball. Cannot be right. He dropped a ball, right? Round though, you see? He dropped round though. Okay? So which one was dropped from the lowest height? W. Which one was dropped from the highest height? Well, I still need to compare Z and X. Compare Z and X. Which one was dropped from a higher height? X. Okay, done? Okay. Okay, let's go to booklet B. Energy, why are you learning energy? Energy. Okay, now let's quickly do. What are the two forces acting on Mr. Lim? On Mr. Lim as he was pushing the cupboard. What are the two forces? Frictional force because he's moving. Anything else? Why gravitational? Because he's on Earth, exactly. Because he's on Earth. Okay, not energy, other force, different. Energy is the next topic. Besides pushing harder, what could Mr. Lim do to decrease the time taken to move it? What can he do? Add lubricant to the where? Can I add lubricant here? So you must say here in the, can I add lubricant here? Will it help? No, right, exactly. No, but yeah, you make you slip and fall, right? That's why. So that's why when we say add lubricant in science must be specific. Okay, so where must I add the lubricant? Add a lubricant. Okay. Add a lubricant to the surface between A and B. Okay, that's how we do it. Now, am I done? Can I move on to the next question like that? Cannot. Why? Because what is missing? Explain your answer. For explain your answer, I need to tell them, right? So what does it do? The lubricant reduces friction between. Okay, somebody continue the sentence. Zairul, continue the sentence. Friction between?
Point A to point B.
No. Remember, what are the two surfaces touching each other? Is point A touching point B? No, right? So think about it. What are the surfaces that are touching?
The cupboard and the
And the
floor.
exactly between the cupboard and the floor. Okay, when there's lesser friction, making it okay. So when it reduces friction, he needs to use a lesser effort to push the cupboard. And when he needs to use a lesser effort, he can move it faster. Is that okay? Okay, we'll stop here for now. Did you all understand the lesson? Okay. Arisa, okay? You won't mistake energy and forces again, okay? Thank you. Bye, guys. Bye. Bring on. No, no, no. Have I marked all? Haven't marked all. Oh, I will. You can bring your one home. Ayana, you can bring it home inside your work. Okay. I'll come back and mark it. Okay? Okay, you can take it home. Go and finish. Oh, you gotta finish. I haven't marked it. I. Look here, I'm going to see you very soon. By now, the right design is already good enough in this time. See, like a pulling force, not pulling. Pulling force, right? Even when it's zero, do I need a pulling force? Can I need, right, of course, so cannot be zero. When the angle is flat, I still need to pull it, but I still need some force to. That's right. Pull straight, man. You pull the thing, but what do you mean? I can pull strong, but I think the same place wouldn't affect. Imagine we have two launchers, you and I. You are stronger than me. You pull it very strong, but the same distance as me, and then we release. Will it affect? Will it affect? Right. So how? Put up. Bye. Put up. Bye. Okay, why I do this way instead? Picture the ball, the shoe is going this way, where is picture? The shoe. Gravity always has. I'm not going to do it. You go, let it run. There you go. Hey, good luck. Are you supposed to let? Never do anything.